I lead the Extreme Robotics Lab. We focus primarily on what's called autonomous or intelligent robotics. So this is, for example, a robot arm and hand that does not need to be controlled by a human with a joystick. It's intelligent, controlled by its own AI and its own vision system. The UK contains nearly 5 million tonnes of legacy nuclear waste. It's the biggest environmental remediation challenge in the whole of Europe. By using robots, we remove the need to send humans into hazardous environments. As we do these things safer and faster, the cost to the taxpayer and the liability reduces. We have some of the best robotics expertise in the world in this country. Cleaning up the environment for future generations provides a motivating reason to get young people engaged in robotics and engineering and science and mathematics.
My team specialises in the development of miniaturised sensors to go into extreme environments deployed on robotic devices and systems. And so that allows us to go into spaces where humans simply couldn't go because it would be too dangerous and humans might even die from those kinds of environments. NCNR is all about robotics for the nuclear sector, and that includes everything from new build through to decommissioning. We're trying to aim our technologies, our miniaturized robotic devices and sensors, into going into extreme environments and characterizing where the hazard lies. And in doing so, that allows the nuclear industry to plan better for how they can clean up nuclear waste problems, or they can speed up build programs such that there's less time and therefore less cost. Pipe crawlers that I'm developing for the nuclear sector, we can translate and take across and deploy them in the oil and gas sector. And equally, with things like my flying drones, we can take them from the nuclear sites that we're deploying them on, and we can deploy them across mining sites in different countries around the world. It's incredibly attractive for all of those sort of early career researchers, the students that want to get into a technology and a career which really makes a difference. This marks the change, I think, for the UK in having a step change in taking robots and making them the norm in the working environment.
We are looking at machine learning methods that allow robots to learn from interaction with their environment, but also to learn from human experience. So we want to involve a human teacher that can show the robot how to perform certain tasks. The most important task that we are looking at is decommissioning of nuclear waste. So where you basically have like a heap of waste objects in front of you, and you need to sort it into different decommission levels of the objects. Basically, the robot should do that in a semi-autonomous way, so he's always assisted by a human operator, but he should help the human operator performing like very complex manipulation tasks. So we can apply it to every domain where we have to manipulate unstructured objects, which is, for example, agriculture technology. How can the robot pick certain fruit for a certain crop autonomously? A healthcare service robotics, or robots in your home, or manufacturing.
Our specific areas are centering around reliability, safety, and performance of embedded systems and microchips. We make them more reliable and we increase the safety of those systems for continuous operation. For the National Center of Nuclear Robotics, that focuses around making these systems much more reliable because they're exposed to severe radiation which will affect the electronics in its operation. These environments are really dangerous for humans to be accessed, and in particular some applications can't be really accessed by human operators at all. We also work on the computer vision and perceptions, where we're particularly focusing around localization and scene understanding of where the robot is placed. It's directly relevant to other areas such as self-driving vehicles, where it's important that they operate very reliable for a prolonged period. If you buy your next self-driving car, you want it to go and maybe work for you for the next 10 years.
Our main interest is in human-robot interaction, and especially that kind of human-robot interaction where there are robots working with humans in close proximity, and the robots can be useful but also could be dangerous. in the nuclear industries. It's unlikely robots would be working on their own, and also unlikely they would be working fully autonomously. There's liable to be some monitoring. Every possible occasion in which we can exclude a person and place a robot in there instead is bound to be useful for literally saving lives. It's applicable very widely in society. For example, if you imagine an older adult living on his or her own in their home, a care robot would have to be behaving very similarly in terms of being useful but not dangerous. We may be moving into a new age, in which robots are with us and amongst us, helping us in many different walks of life.
We are creating robots that are made from soft materials, and we take inspiration from biology, and here we try to create small sensors that can be integrated with robotic hands so that these hands get a better feel for the environment. These robots are particularly useful to enter areas that have only a very small access point. Humans cannot go in there to, for example, cut nuclear waste, etc. And all that is supported by the force and tactile sensing work we are doing, so that we can get a feel for the interaction in a haptic kind of form. People with injuries, stroke patients, for example, need to retrain their body. And here, I believe, soft robotic devices are particularly suitable to help and provide, for example, a soft exoskeleton to improve a person's health over time. And that combined with the tactile and force sensing work we're doing, I think we can develop the prosthetic devices of the future.